let's take a look at y equals the square root of 2x plus 3, and let's start the process of graphing this. All right. In order to graph it, I want to be a little clearer on another way to possibly think about this. We want the radicand to be a perfect square. All right. We want it to be a perfect square because then the final step is going to be taking the square root of it. And if it's a square root of a perfect square, we have an output of a very easy number. All right. So over here to the side, I'm going to make a list of my perfect squares. The first couple, 0, 1, and then 4, 9, 16. That's fine. That's enough. Okay. Meaning, I want my radicand, I want my 2x plus 3 to equal 0, or equal to be 1, or equal to be 4, or equal to be 9, or equal to be 16. Because if it's equal to any of them, my last step is going to be finding the square root, and my output would then be a perfect square. Okay? So in order to create our table, I'm just going to put PS for perfect square. Here's my perfect squares. All right? Over here is where I'll make my table. These are going to be my inputs, the ones I'm going to input, and this is going to be the output. Now my outputs, I want my outputs to be perfect squares. All right, so this is where it's a little bit backwards. All right, and that kind of happens. Our graph, you'll learn this later in future math courses. This is almost as if the x and the y have switched places in a way. Anyway, uh, so what I'm going to do is I'm going to make my radicand 2x plus 3. I'm going to make that equal to be 0. Okay, I'm going to forget about the radical sign, and I'm just going to make this equal to 0. Okay, the reason is when I solve this equation, 2x equals negative 3, divide by 2, x equals negative 3 halves, or I'll just put negative 1.5. When x is negative 1.5, this will equal 0 when I plug it in. Meaning, when I plug negative 1.5 in for 2, multiply it by 2, I get negative 3. Negative 3 plus 3 is 0. My output will be 0. The square root of 0 is 0. Okay? Now, the next one I'm going to do it right next to it. Okay? I'm going to make my radicand 2x plus 3. I'm going to make it equal to the next perfect square number. That's where that 0 came from, or was from my list. I'm going to make it equal to 1. Because if this is equal to 1, the square root of 1 will also be 1. I'm going to take away 3. So 2x equals negative 2. Divide by 2. X equals negative 1. So when x is negative 1, I want to plug negative 1 in here. 2 times negative 1 is negative 2. Plus 3 is 1. The square root of 1 is 1. Check. I'm going to continue. I'm going to make my radicand 2x plus 3. I'm going to make it equal to my next perfect square, which is 4. I'm going to solve for x, because whenever I solve for x, I'm going to plug in. It will make this into a perfect square. 2x equals 1, divided by 2, x is equal to 1/2. Sure, it may not be ideal of a fraction, but it's not that bad. Since I dealt with decimals, I'll continue with decimals and put 0.5. But when I plug 0.5 in here, 2 times a half is 1. 1 plus 3 is 4. And the square root of 4 is 2. All right, so this is going to be, my output's going to be 2. My next one I'm going to do is 9. I want 2x plus 3 to equal 9. I'm going to solve for x. 2x equals 6 divided by 2, x equals 3. So when x equals 3, when I plug 3 in for my x value, 2 times 3 is 6, 6 plus 3 is 9. The square root of that will give me 3. All right, I do want you to note my y values are the square roots of the perfect squares. Okay, meaning I know this one's going to be 4. The next one I'm going to do is 4. When I make 2x plus 3 equal to be 16 and solve it for x equals 13 halves, or what's that, 6.5? This will be 6.5. All right. So now what I would do is I would go and I would plot these points, and it would make a square root function.